Hi everyone, this is Madhav, and recently I have been very lucky in being able to explore a software called Fusion 360. It's this 3D printing software. That's what most people would use it for. But I got to realize that it has a lot more cool functionalities, all for a cheap price of being free for a student like me. So what we're going to do today is I'm going to explore some of the physicsy sides of Fusion 360, specifically in how we can simulate different forces in terms of engineering designs. And I thought, what's the most engineering topic that we could pick? Well, it's building bridges. So I'm going to figure out how to build a bridge in Fusion 360 and make sure that my bridge, like it would actually hold up in real life. So let's dive into it. So in the first iteration here, all that I did was just randomly guesstimate where do I put the supports, which dimensions do I need. So here we have 100-meter long section of the bridge, and in the middle we have some asphalt, and around that some iron railings, and at the bottom we have just some concrete pillars to hold everything up. And now we just randomly estimated how many we need. I was hoping that it would be enough. So I went over to simulate what would happen when I just checked, does this bridge hold up in the weight? Just the weight, no added clouds on top, just the weight. Can it handle all the pressure? And so when I looked at the results, well, you can see that doesn't look great. It looks like a Hot Wheels track here. And I can try to animate, but there's no real, you know, meaning to the animation right now because it's just deforming amidst the weight. So it's not like there's some added pressure. It's just like this would naturally happen when the bridge were actually in service right now. So what I need to do now is one, probably update the size of these different tracks. So make these support columns larger. And then two, probably add some supports to these middle regions. I'm thinking some triangular beams so that it's better supported. But hey, at the very least, currently it looks like we have some artistic pieces here. Looks like interesting art going on, but not a great bridge. So let's go on to the next iteration. So we now have the second iteration of the bridge, and as you can see, I have added these little arches in the middle of the columns so that the weight from these middle sections is more evenly distributed across the columns. And so when we go over to the simulation to test whether this works, well, it does and it doesn't. You can see in the bridge, it still looks a little bit like it came out of Dr. Seuss, and it still looks like it's a bit, topsy-turvy. However, when we compare it to the results of, other bridges, well, this one's even more. It looks even more like it's a roller coaster. So making some progress. I think one of the things that is going wrong here is I think I'm not setting up my study correctly because I can't help but notice. So when I animate these results, it really does look like the bridge is falling down. And I'm just like, what? How is that area contracting? That does not make sense to me. That's quite bizarre. So when I set up these studies, you can see these little locks. These are things that I say cannot move. And I thought if I just, said the bottom of the bridge cannot move, well, that should also apply, propagate its way up to the top of the bridge. But I'm going to try running a simulation where I change what are called the constraints so that maybe we can avoid this issue. So regarding the study setup, I think I figured out what the problem is, and it's taken quite a few studies of experimentation to get there. If I look at the results, it seems like no matter which things I fix, which things I say cannot move, there's always like these little bulges happening in the road surface right here. And when I when I try to even just fix things that don't even make sense to fix, like this still happens. You still have these weird bulges. The road surface it just doesn't work, which was very frustrating to me. But then I thought a little bit more about why that could be happening. So if I look at the results, well, when I look at the materials that I used, the surface of the road, well, it's made out of stone. It shouldn't be that flexible. And I'm not sure, you know, why Fusion 360 might treat stone like that, but I'm afraid I just cannot. I just cannot make a realistic physics simulation if it does treat stone in this way. And I'm not sure what to do about that. So what I'm going to do is I'm just going to try and make sure that nothing at all can move. Like literally everything is fixed, every single face and point. And that's not very realistic in a bridge, but I'm not sure what else to do because yeah, Fusion 360, I don't understand your material properties going on here. So I have the first results, and it's the actually first valid result. So you can see here that the stress tends to build up around these support areas at the bottom, which makes sense. The columns are bearing the weights, but it's not a bunch of stress at all. 0.03 megapascals, that's a unit of how much force there is on a given area. So in this load case, that's just the case that I've made for the bridge in terms of how much weight it should support. I've put in I've put in about 50 cars worth of pressure on top of the bridge. So it's a 100-meter bridge. I figured, hey, there's not going to be cars that are, less than 2 meters long. So you literally cannot fit more than 50 cars, and it appears to be just fine for 50 cars worth. I could probably take out a bunch of these columns here and still be fine. So all in all, we have made a bridge successfully. It's not a great bridge. It's not a great study because, there are some assumptions being made that I am not particularly fond of. However, it's cool to see the results, and it's cool to learn a little bit more about which factors I have to think carefully about when making these kinds of studies. And thank Lord that I'm going to engineering school, so I don't just, play around with the constraints just to see what works, and instead actually know a little bit more of the theory. So I'll look forward to revisiting stuff like this in the future.